All right, so moving on to section 4 of chapter 9, we're looking at special cases with our uh, multiplying binomials together. So sometimes there are some shortcuts for us that we can use when we're multiplying these binomials together so we don't have to go through all the multiplication every time. So that's what we're going to be looking at here. So the first thing is when you're squaring binomials. So when you're squaring a binomial, that means you're given a binomial, x plus 5, and you're giving it to a second power. And when you're doing that to a second power, what's end up happening is you're taking x plus 5 times x plus 5. So you're multiplying both of them together. And so when you do that, let's say we're using our box, we go x times x, or FOIL, x times x, and then we go x times 5, and then x times 5, and then 5 times 5. And when we multiply all that together and we simplify it, we end up with this number right here, x squared plus 10x plus 25. Now, if we do this with any type of binomial, x plus 6, let's say, and we're squaring that, the same thing is going to happen. We're going to have an x squared, but in the middle we're going to have a 12x, and the last part's going to be 36. Okay? And so what's happening here is that when we're squaring a binomial, we end up with a kind of a shortcut. We square the first number, we square the last number, and then in the middle what we do is we take the two numbers, multiply them together, and then double it. Okay? 5 times x times 2 is 10x. 2 times x times 2 times 6 gets us 12x. Okay. All right. So these are kind of shortcuts. You probably want to write these down so that you can use them. One is if you're adding the two together that you're squaring, the other one's you're subtracting. And you notice the only difference is right here. Okay. The adding one stays plus 2x. The other one is minus 2x. Minus 2ab. Okay, so if we take this one, I'm going to give you guys a second. I want you to see if you can, using the shortcut, find what the answer would be to multiply this through. Okay, so when you multiply it through, you should have squared the first number, which would have gotten you x squared. Then you go 2 times x times 4, and then 4 squared. And so when we multiply all those together, we end up with x squared plus 8x plus 16. So as you see, we don't have to go through the whole box if we can use this shortcut. And of course, you don't have to use this shortcut if you are more comfortable with the box. Okay, so now take a second, do this one. Okay, so now with this one, when we multiply it together, we'd go x squared plus, nope, not plus, it'd be minus 18x plus 81. Okay, so as you see, the difference is that since it's x minus, we're going to be dealing with a minus 2ab for this one. Okay. All right, so now this is where you might see it a little bit more complicated, but again, the same process still applies. You're going to square the first number, okay? So you square 3x, and you square the last number, 8y. You square both of those. Then you multiply 3x times 8y, and then double those, or multiply by 2. 3x gets you 9x squared, plus 48xy, plus 64y squared. Okay? And that would end up being our answer. Okay? So again, it still works even if you don't just have an x or just have a number. You still can use this rule all the way through. Okay. Now the next one is if we have two numbers that are, or two binomials that look almost exactly the same, except the only difference is that one's adding and one's subtracting. So x plus 8, x minus 8. Our answer that we end up getting is x minus 16. And the reason, which the box will show up to show you, when we multiply this through with the boxes, you see we get our x and x squared. Then we have x times positive 8 and negative 8 times x. And these, when added together, will always cancel out. And so since those cancel out, what we end up having is just the first term and the last term. And when we have a case like this, what we end up doing is that we end up just squaring the first, squaring the last, and we subtract it. And this is called the difference of squares. So when we square the first, square the last, and put a subtraction between it, what's end up happening is that we're taking a minus b times a plus b. Okay? And that's another one that you might want to write down so that you can use for future reference. Okay, so take a second. I want you to simplify all these and see if you can find what the answers are. Okay, so with the first one, we should end up with squaring the first, squaring the last, put a subtraction in between, getting us x squared minus 49. For the second one, we're going to square the first one. 2x to the second power ends up with 4x squared minus 64. And the last one, we can also do this with variables and end up being x squared minus y squared. But again, the one thing you do want to watch out for is make sure that these signs are different. If they are the same, you end up using one of your perfect squares. So it goes the other way. Okay. All right, that's basically it for section 4. And for these, I would recommend trying to use these rules so you can get used to them and you can help remember them. Otherwise, you might forget them and then you'll have to keep doing it the long way. Okay, so these are kind of shortcuts for you to help you get these problems done faster.